Hello everyone. Today we are going to see bilinear transformation. W equal to AZ plus B by CZ plus D, where A, B, C, D are complex constants and AD minus BC not equal to 0 is known as bilinear transformation. A transformation of this form is called as bilinear transformation, and this bilinear transformation is also called as Mobius transformation or linear fractional transformation. And the inverse of this transformation, bilinear transformation, is also a bilinear transformation. Next, we are going to see fixed point or invariant points. The point is said to be a fixed point or invariant point if the image of the point is itself under any transformation. So if an image of a point z under the transformation w equal to f of z is itself, then the point is called as fixed point, otherwise called as invariant point of the transformation. Thus, the fixed point is given by z equal to f of z. For example, take w equal to z by z minus 2. We need to find what is the fixed point of this transformation. So, image itself means we need to put w equal to z in that transformation. Then, if you simplify this further, you will get it as z square minus 2z equal to z. And if you simplify this further, you will get 2 points from this step, which is z equal to 0 and z equal to 3. These 2 points are called as fixed points. So easily you can find the fixed points where the image of the transformation is itself. Next we are going to see cross ratio. 4 points z1, z2, z3, z4 in the z plane. Take 4 points in the z plane. Then the ratio z1 minus z2 into z3 minus z4 divided by z1 minus z4 into z3 minus z2 is called the cross ratio of these points. So cross ratio is defined like this for 4 points in the z plane. Next comes a property based upon this cross ratio. The property says that the cross ratio of 4 points is invariant under a bilinear transformation. So cross ratio of 4 points already defined. So that is given here as invariant. So what is meant by invariant? The image is itself. So we are getting a result from this property, that is left hand side the cross ratio is written here in terms of W, right hand side cross ratio is written in terms of Z. So this is the property which is otherwise called as a 4-point formula of bilinear transformation. If you want to find the bilinear transformation, if the 4 points and their image is given, we can apply this to find the bilinear transformation. And next comes a note for 3 points are given in the z plane and the image of those 3 points in the w plane is given. Then we can find the bilinear transformation using the cross ratio property. So the property easily can remember, it is w minus w1 into w2 minus w3. Numerator it is w, then suffix 1, 2, 3. Then denominator it is 1, 2, 3, then w. That is w1 minus w2 into w3 minus w. So whatever you have written in terms of w in the left hand side, similar to that, we are writing that in the right hand side in terms of z. So it is z minus z1 into z2 minus z3 divided by z minus z1. It should be z1 minus z2 into z3 minus z. So for doing examples with 3 points, this note will be useful. So next we are going to see the example. Find the bilinear transformation which maps the points, 3 points given. One is 0, next is minus I, then is minus 1. Then into the image is given as I, 1 and 0. So first we need to write what are the given points. That is the given point, what is Z1? Z1 is 0, Z2 is minus I and Z3 is minus 1. Then similarly first point in W, W1 is I, W2 is 1, W3 is 0. Then we need to apply the cross ratio property for 3 points and we need to find the bilinear transformation. So just we need to write the cross ratio property W minus W1, then W2 minus W3 by W1 minus W2 into W3 minus W4. So it is W123 here, denominator 123W. Similarly in the right hand side. Then substitute what is W1, W2, W3 in the left hand side, what is Z1, Z2, Z3 in the right hand side. Then after substituting, we need to simplify further and we need to express the bilinear transformation as W equal to function of Z. We need to bring W's one side and all other terms to the other side and simplify further. So if you cross multiply, you will be getting terms like this and expand these terms fully. After expanding, collect the W terms in one side and all other terms in the right hand side. Then you will get W is equal to 1 plus Z by minus I into 1 minus Z. This is the required bilinear transformation. Next is an example shown to you. If infinity is one of the point in Z given or W given or both are given, how to find the bilinear transformation. So if any point is given as undefined infinity, first we need to simplify the cross ratio formula and get rid of that point from the cross ratio. Otherwise, we need to retain that point in the denominator so that if you substitute the point infinity, 1 by infinity, that point, that term will become 0. So first, the given points we are writing in terms of Z1, Z2, Z3, W1, W2, W3. So if you see, it's given Z1 infinity and W3 infinity. So take the cross ratio property to find the bilinear transformation. So after writing this cross ratio property, whichever point is infinity, we need to take that point as common and simplify that with the denominator. See to that it is there in the denominator and others getting cancelled. So if you see the left hand side, W3 I need to take it as common. If you see the right hand side, Z1 I should take it as common. So that simplification is shown here. So W3 is taken common here, both in the numerator and denominator. So this will get cancelled here and remaining term is there in the denominator. Similarly, right hand side Z1 taken as common and that is cancelling with the denominator. Remaining, if you see, Z1 is there in the denominator. So if you substitute infinity, this term will become 0. Then further if you simplify, you will get the bilinear transformation W equal to minus 1 by Z. So if infinity comes, this simplification you need to do before substituting the values in the cross ratio property. Then easily you can understand how to simplify and get it. Then other problems are listed here for you to try later on. Thank you.